what is light? There is more light than what you think you see. The lights that you can see are only a small part of the whole spectrum of what there is in the world of light. Many of these lights are used for everyday objects such as microwaves and cell phones, radios, X-rays.
As you can see, we have a very full chart. This is all the light that you can see, and it can be divided into two groups. First is the invisible light that you can't see, which consists of radio waves, microwave, X-rays, etc. And then there's the visible light, which you're familiar with, that you see in the rainbow, light coming out of the bulb. So the thing about white light, the visible light, is that can be split up. It was first split up by our friend Newton, and it can be, as you see, for yourself through this, and be split up.
So please hold it up to your eyes, look slightly away from the light that you were directly looking at, and you should be able to see various colors of the rainbow, depending on what light you're looking at.
So why can't we see all the light? There are a lot of invisible light that we can't see.
So to show you that, we made a little demonstration. Kind of a volunteer, please. Two volunteers, please. All right. Please place the pieces in the puzzle to fill up all the holes.
Okay.
Now, if you notice, there are two that are left out. This is our UV light, and
this is the mysterious infrared light. So we're wondering, why can't we see this light? Well, there are a lot of reasons. First of all, your eye is kind of like a puzzle. So
I just showed you.
yes. So there's this unique property of light called the frequency, which is much like the shape of pieces of puzzle. So each light has a different shape, much like each light has a different frequency. So just like these pieces don't fit in your puzzle, which is representing your eye, these lights have frequencies which you can't see because you don't have a receptor for it. Okay. Yeah. So we're going to talk about two invisible light. First off is the infrared.
Guys, he's holding right now.
You can't see it.
Or can you?
Question we can answer.
Here we have your basic webcam.
Yep.
The guy's just going to shine the light into the webcam. Okay. You can't see it there. Well, you can probably see it through that. But on the screen, my hand's not blocking it.
There you go.
There's your light.
So there is actually light coming out of that, which you can see.
And why would we make an LED bulb if we can't actually see the light without using a camera or a webcam?
With the remote.
We point the remote at the webcam. You'll see this light flashing when I press the button. And that is how your remote signals your TV to raise, lower volume, change channel, any function on your remote. We'll be using infrared light.
These type of lights are called smart lights because they can be used to achieve complex tasks like remote controlling.
Things more complicated than illuminating a room.
Yes. Going back to the slide. Infrared light is everywhere. First of all, it serves as plant food. It allows the plant to use the light. I mean, it comes out from the sun, the infrared, and the infrared itself allows plant to produce food. Next up, we have the criminal detection. Infrared can be used to detect criminals. Would you explain why that is?
Because criminals, like all people, give off heat. And that using a camera that specifically searches for heat or infrared, they can easily be found through objects that are cold, such as a large wall.
And then we have our infection detection. It can be used to detect infections. And we showed you the remote control. The next infrared, the invisible light.
Next invisible light that we're going to talk about is ultraviolet light.
Okay.
And ultraviolet light is everywhere too. Most commonly found in sunlight. So to show you that it does in fact exist, you see we have these little two beads here. Now in this normal light setting, they're clear. But if we were to put it under our black light, which is actually a UV light, more on this spectrum, which is why it appears to be blue and purple, but it also contains UV, this one bulb. So after exposing it to the UV light for a little bit of time, the beads are now colored. And we can't turn off the lights. I don't know how to explain this very well.
Other experiment that we're going to do is we're going to make this special type of tonic water glow. You can see it glows under UV because it has a special chemical in it that absorbs this UV to produce visible light itself, which is another proof that UV actually exists. This would work better than dark UV. UV light is everywhere too. It can be used for germ detection, especially these sort of lights.
Used for finding pet stains.
Yep. It can be used in artificial tanning.
People would like that.
And it can be very harmful as well. That is why you use sunscreen when you go out, because it can actually damage your skin if you don't. Much like the picture here.
And why you shouldn't get an artificial tan.
Questions?